8-7, let's do this. All right, so this is a long section, so bear with me. This is going to be a slow process, so make sure you watch this a couple times if you need to. Okay, so here we go. Arcs and angles. They are formed by intersecting chords, secants, and tangents. We have three relationships here. So we have one where the intersecting chords, secants, or tangents are inside the circle. We have another where they are on the circle, so at a point of tangency. And we have another, let's do not dark green, blue, where it's outside the circle. Where it intersects is outside the circle. They're going to have three different relationships, and they're cool. So the first one we're going to be talking about is when they intersect inside the circle. So let's go back to purple. So looking at angle 1 here. So we're looking at angle 1. So let's remember that angle 1, let's make this 3, are going to be the same angle because they're vertical angles. So angle 1 is going to have a relationship between these arcs. So AD, whoops, Kindle fell, not Kindle, iPad fell. Fix this. Yeah, between AD, and BC. All right, so angle 1 and angle 3 will have a relationship between those two arcs. So angle 1 is actually going to equal the average of those two arcs. So say we had the measure of arc AD plus the measure of arc BC. So the measure of this arc plus the measure of this arc and the average of those. So we divide by 2 because there's 2 of them. That's pretty cool. So that is a cool relationship. The next we're going to do is with angle 2. And remember, angle 2 and angle 4 are going to be the same because they're vertical angles. And they're going to have a relationship with AB and DC. It's going to be the same thing. It's going to be the average of those two arcs. So measure of arc AB and measure of arc DC. So the average of those is going to equal angle 2. So let's do some examples of that. I'm going to do all the even of these examples. So bear with me. Here we go. We're trying to find the measure of STR here. So we're trying to find this angle. What is it? So we know the arcs we need are this one and this one. Since it's the first example, it would make sense that they gave us that. So we know X is going to equal, or STR is going to equal the average of PQ, the measure of arc PQ, plus the measure of arc SR. So let's just say that's equal to 1/2 of, what's the measure of arc PQ? It tells us 186, and SR is 112. So what is that equal to? 1/2 of 298, which is 149 degrees. Good. So we know X, this angle, is going to be 149 degrees, which means that this angle is also going to be 149 degrees because they're vertical angles. There we go. All right, so we're now looking for the measure of arc LK. So before, we used this formula to find the measure of one of the angles. Now we're going to use it to find the measure of an arc. So we have an angle, so 62. This angle is going to have a relationship with this arc and this arc. So we know that the measure of angle LNK equals 62 degrees. And we also know the measure of angle LNK equals 1/2 of the measure of arc JM plus the measure of arc LK. So we know that angle. So we know that is 62 degrees. Do we know either of those arcs? Yep, we know JM to be 74 degrees. We just need to find the measure of angle, or the measure of arc LK. That's what we're looking for. So we need to solve for that. So let's make this a little bit smaller. There we go. Let's get that arc back. All right, so how do we get rid of that half? We can multiply both sides by 2. Let's change colors. By 2. By 2. That gives us 124. 2 times 1/2 gives us 1, so we get 74 plus the measure of arc LK. Solve for measure of arc LK, subtract 74 from both sides, and we get our answer, where measure of LK is going to be equal to 50 degrees. Done. So if we're finding angles, we can always just use our formula. For finding an arc, we use our angle to help us. So same thing. All right, let's find the measure of arc QD. QUT. Here we go. So QT, that is this arc. So the relationship between this arc is going to be either this angle or this angle. And we're going to use this arc. So do we have either of those angles? We don't. So we have to actually find that. So we have to find either U or what do we want to call this? L. Either way, it's going to be the same thing, the vertical angles. So what is U going to be? We know this is 180. So 180 minus 79 is going to be 101. So this is going to be 101 degrees. So if we have the angle, we have an arc, we can find the other arc. So 101 degrees equals 1/2 of QD plus 95 degrees. Multiply both sides by 2, we get 202 equals QD plus 95. 2 times 1/2 gives us 1, so that would cancel out. So we get QD equals 202 minus 95, which is going to be 107 degrees. And we are done. Okay. Okay. Let's go to the next scenario. So the next scenario is if the intersecting secants, chords, whatever, is on the circle. So here we go. Our point of tangency. If it's on the circle, we treat each angle as if it is an inscribed angle. It's the same thing. So measure of angle 1 is going to equal half of the arc. Half of the measure of arc AB. Like an inscribed angle, same thing. And then, if we were trying to find the measure of angle 2, it's going to be half of that arc. So half of the measure of ACB. There we go. So if you want to put your parentheses, you can. It's the same as an inscribed angle, basically. So let's do number 8. Because we'll stick with the even here. All right, so we have this arc right here. That's 192, which means we could find the other arc if we wanted to pretty easily because the whole arc is going to be 360. So we have to then see what angle are we looking for. We're looking for DBC. We're looking for this angle. This angle right here. So the arc we need is actually this. So this is going to be half of DB, arc DB, arc DB. Okay, so we need to find arc DB. So arc DB, measure of arc DB is going to equal 360 minus 192. And what is 360 minus 192? That is 168. So the measure of angle DBC equals 1/2 times 168 degrees. 168. So that's what that angle here is going to equal to. So that is half of 168 is 84. Doink. All right, number 10. Same idea. Let's go back to number 7 real quick, because they always give you an easy one right off the bat. DEG, DEG, we're looking for this angle. We know that we need this arc, and they give that to us. So we know this angle is going to equal half of the big arc, and the big arc is 308 degrees. So half of 308 degrees is 154 degrees. Piece of cake. Number 10, here we go. It gives us this angle right here. It's 23 degrees. Right here, 23 degrees. That goes with this arc. We are looking for KMN. No, KNM. So that is going to be a different color because we're going to look for a different angle. We actually need this angle right here. Oh, crap. We are actually looking for this angle right here. God, that's pretty cool though. So we're looking for this angle right here. If we know this angle is 23 degrees, can we find this angle? We can, pretty easy. That's going to equal, theta is going to equal 180 minus 23. So theta is going to equal 157. So 157 is this. So now we are looking for this arc. So we have the angle. Now we can find the arc. So the measure of angle. Now let's just put theta since we already have it. So theta is going to equal 1/2 of that beastly arc, measure of KNM. And since we know theta is 157, we can find the measure of KNM pretty easily. We just get rid of that 1/2 by multiplying both sides by 2. So we get 314. So we multiply by 2, multiply by 2, 2 and 1/2 cancel out. We get 314 equals the measure of KNM. Boom. And we are done. Look at that. That is the second rule. That is if we have the point of intersection on the circle. We treat it just as we would on inscribed angle. So you should know inscribed angles now. This is the hard one. This is exterior intersections. Not hard, but a little bit more challenging than the other two. So if we are trying to find this angle here, the one that's outside the circle, where those two secants intersect outside the circle, it's going to be the difference between the arcs. So instead of finding the average of the arcs, it's going to be the difference between them. And it's always going to be the one furthest from it and biggest. That's going to be the one we subtract the little one from. So for example, the measure of angle A is going to equal 1/2. The big arc, so CE, this guy, minus the little baby arc, BD, and half of that. That's going to equal A. Okay, it's going to be the same thing for this guy over here. The intersection's outside the circle, not on the circle. It's outside, it's not in the circle, it's not on the circle, it's outside the circle. So we're going to take the big arc that's between the angles and subtract the little arc that's between the angles and take half of that. So the half is going to be in red, and then the parentheses will be in red, and then we'll go back to the orange. That's going to give us our BD arc, minus will be in red, and then we go back to green. That's going to be our little baby arc, CB. Okay, we take the bigger arc, subtract the little arc, and we divide it by 2, or we multiply by 1/2. Same thing. Okay, let's do this guy. Also, intersecting outside the circle. This time, both are tangent to the circle. So we would know if they are tangent, it tells us they are. These would be the same. Not going to be helpful, but still works. So we have two secants in the first one, a secant and a tangent in the second one, and two tangents in the third. All of them intersect outside the circle, and that's what's important. So we have our big arc that's between the angles, this guy, and we're going to subtract the little arc inside the angles, this guy, and we'll take half. So let's go back. Orange will be the half. Doink, doink, doink. Then we have our red. So that's going to be the measure of BDC minus the green, the little guy, the measure of, let's do CB. And there we go. Now let's do some. Let's do 11 as well, just because it starts us off easy. We're trying to find KLM. KLM. So we're trying to find this angle. I'll just call it X. So X is going to be equal to, remember, the difference between the big angle and the little angle. Let's change it to blue. The little, sorry, not the angle, the big arc and the little arc. So we have the big arc. Big arc is going to be 140. And the little arc is going to be 66. Not too bad. So it's going to be 1/2 of 74. So 1/2 of 74 is just 37. So 37 degrees is what that angle is going to be equal to. That is cool. All right, number 12, here we go. We are trying to find the measure of BCD. That's this angle again, this angle. We need this arc, so let's get the colors ready. We need this arc minus this arc. We do not have the orange arc. We do have the red arc, but we do not have the orange arc. So that's the first thing we got to do. We got to find the orange arc. We do know these whole arcs right here. I'm going to change it to a different color, purple. We know the whole purple arc is going to be a semicircle because this guy is a diameter. So that is good to know. So we know we have 67, 94. We can find what the orange is. So orange is going to be, so orange equals 67 plus 94. Oh, let me erase that. Orange equals, let's do red, 67, 180 minus 67 plus 94. That's going to give us our orange. And what is our orange then? Our orange is going to equal 19 degrees. So that is going to give us 19 degrees. So our X is going to equal 1/2 our big arc, which is 67 degrees inside the angle, minus our little arc inside the angle, which is 19 degrees. So 1/2 of 48 is going to equal 24 degrees. That is what X is going to equal. Cool. Next, number 14. Here we go. We have the angle. We have one of the arcs. We're looking for the big arc. So we're looking for this. We are given this, and we are given the angle here. So we know that 35 degrees is going to equal 1/2 the big arc, the red arc. So we don't know what that is. We'll call it X. X minus the little arc, which is in orange, 46. So we just got to solve for X here. What I like to do is get rid of the fractions right away. I don't want that 1/2 there. So I multiply both the sides by 2. And I get 70 equals X minus 46. 2 times 1/2 gives us 1. That's why. So add 46 to both sides. I get 116 equals X. Oh, wow. And we are done. That's nice. So we found the arc right away. So the measure of QU equals 116 degrees. Whoa, that doesn't look like an arc. There we go. All right. On to the next, 16. We are looking for ABC. We are looking for x here, which means we need the big arc here and the little arc here. We have the little arc. We need the big arc. So we know that the whole arc, let's change to green, the whole arc is equal to 360. So we have most of it. We just need, so we have 88, 62, we just need the orange. So we know that 88, let's call this y, plus 62 plus y equals 360. So we can solve for y and say it equals 210. And so since y equals 210, we can solve for this pretty nicely. We know x, which is in blue, is going to equal, let's get our 1/2 parentheses minus, orange is going to be 210, our big arc minus our little arc, so that's in purple, 62. So 1/2 of 148 is going to equal 74 degrees. So x equals 74 degrees. Not bad. 2 more. Yes. So 18. We are looking for the measure of arc MK. Okay, so we have that. So we have, So we have this arc. We're looking for the little arc, and we have the angle. Okay, not bad. So let's do it. We have 56, let's make this color orange. So we have 56 degrees equals 1/2. Big arc, green. Oops, wrong green. Green, 160 minus, we'll call this x. Purple will be x. We need to solve for x. So get rid of the 1/2 here. Multiply both sides by 2. 2. We get 112 equals 160 minus x. All right, so we can get the 160 to one side. Depends on how you want to do this. I would add the x to both sides. So I would get x plus 112 equals 160, and then I would subtract the 112. So I would end up with 48 degrees. That would be the measure of the arc. So measure of MK equals 48 degrees. There we go. And last one. Woo! We have measure of CD. Oh no, we are looking for this angle measure, which means we need this arc and this arc. Luckily, they gave us one of them. So we are looking for x here. This arc measure. Pretty easy to find because the whole circle is 360. So x is going to be equal to 360 minus 106. So x is going to be equal to 254. Nice. So we have purple x. Oh, I should have changed that to a y then so we don't get confused. So x is the angle. X is going to be 1/2. Big angle, or big arc is 254 minus little arc, which is 106. So x is going to be equal to 74 degrees, and we are done. So we are going to be combining arcs, angles, and algebra soon. I'm going to do some of these with you. Should I? Yeah, let's do it. Okay, so we are looking for this angle inside here. Ding, 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 dong. Yep, let's do it. So, solve for x. We know when we have intersecting chords like we do here, this angle inside, so 8x plus 34 is going to equal half, or the average of these two arcs. So the average of those two arcs. So that means we add them together. And we can solve for x. We can multiply both sides by 2 to get rid of the 1/2. So we get 16x plus 64 equals 159 plus 53. And we solve. 16x plus 64 equals 212. 16x equals 212 minus 34. Sorry, minus 64, which is 150. Wait, 100. So 210. Nope, 148. So that is 52 plus 12. Yeah, 148, which means x is going to be equal to 9. Boom, we did it. So we were just finding x. So number 4, same kind of idea. Going to my southern accent once in a while. All right, so this is intersecting at a tangency, which means this angle right here is going to be half of this inscribed angle right here. Since we don't know that inscribed angle, it's quite difficult. But since we have the angle, we know it's going to be double it. So this arc is going to be 46 degrees because it's similar to the inscribed angle, right? So it's going to be double that. The central angle would be equal. The inscribed will be half. So half of 46 is 23. That makes sense. And we know the whole arc is 360. So we know 14x minus 22 plus 46 equals 360. And we solve for x. That's how you would do it. Okay, number 6. Here we go. So we have our external angle here. So we'll call this, I already gave it to us, 4x plus 13. The arcs we need are, we need this arc and we need this arc. We only have 86, so we need the green. So the green is going to be, let's change it to gray. So we get the green is going to be 360 minus 74 minus 86 is going to equal what we'll call this y. So y is going to be, let's see, 200? 200. So since y is 200, we can now solve. So we know 4x plus 13 is equal to half the furthest angle first, so that is going to be 200 minus our blue angle, 86. So 4x plus 13 equals half of 114, which is 57. And we saw 4x equals 44, x equals 11. Done. How many more we got here? Okay, I'll finish them. So I'll just do the even. Number 8. Okay, JM. We know JM is 10x plus 9. We know NL is 28x plus 17. And we know the measure of NKL is 16x plus 19. Woo! We need to find NKL. So first we got to find x. So we know 16x plus 19, plus 19 is going to equal 1/2 of 10x plus 9 plus 28x plus 17. Remember, we're looking for the average of those. This angle equals the average of the two arcs. So we got that. So we have 16x plus 19 equals 1/2 of 38x plus 26. We could distribute that 1/2. We get 16x, or we can multiply both sides by 2. It doesn't matter. That would give us 19x plus 13 because we multiplied it in. So we solve. Subtract over. We get 3x plus 13 equals 19. 3x equals 6, x equals 2. So if x equals 2, we can find the measure of NKL. So remember, NKL equals 16x plus 19, so 16 times 2 plus 19 equals 32 plus 19, which is 51 degrees. That is the measure of NKL. That's a tricky one. Hopefully you can follow that. Again, I'm going a little fast, so maybe you're going to have to watch the video a couple times, or at least that problem. Be happy to answer questions you have as well. So here we go. We have an intersecting, what do we got? We got intersecting line. We have a intersecting tangent line and an intersecting secant line at a point of tangency. So that means this is going to be the same as finding, remember, the inscribed angle, and then same for this guy right here. Ooh. Same for this guy with this arc. So let's see what we're looking for here. So they give us TSV. So TSV, this is 6x plus 17. That's this angle. And it gives us arc SV. Good. So we know 6x plus 17 is going to be half of that arc. And that's going to be 15x plus 13. We need to find SUV. Oh boy. So we need to find this guy. First we need to find x then. So we know that 6x plus 17 is going to equal half of 15x plus 13. Right? The inscribed angle is half of the arc. They are equal if it's half of the arc. So we could distribute 1/2 times 15x, but that starts giving us fractions, and I don't really want to work with that. So I'm going to multiply both sides by 2. 2 times 1/2. So let's do the first side, left side first. 12x plus 34. 2 times 1/2 is 1, so we get 15x plus 13. So subtract over. 3x plus 13 equals 34. Bring it over. We get 3x equals 21, x equals 7. So if x equals 7, we can find the arc length of SV. So if SV is this guy, that's going to be 15 times 7 plus 13. So what is 15 times 7 plus 13? That is equal to 118 degrees. So if this guy, I'm going to erase it. I keep saying this guy. So this whole arc right here is 118 degrees. Can we find what the green is over here, x? We can, because the whole arc is 360. So x is going to be 360 minus 118, which is going to be equal to 242 degrees. And so instead of calling it x, we'll call it the measure of SUV, which my mom just bought in the US, an SUV. Okay, there's number 10, tricky. Last one we'll do, here we go. If the measure of NJ, so this arc right here, ooh, that was bad drawing, is 170 degrees. Is that degrees or a 0? Let's do this whole thing again. That was not good. Oh, just as bad. 170 degrees. And we know that MK is 5x plus 8. And we also know that this angle right here is 4x plus 3. We need to find that angle. All right, so here we go. We know that this is intersecting outside the circle. We have two secants intersecting outside the circle. So we know that 4x plus 3, that angle there, is going to equal 1/2 of the difference between those two. So we take our biggest arc and we subtract the little arc, 5x plus 8. Okay, so we could do half of everything by distributing. That seems more difficult. So let's just get rid of that 1/2 by multiplying both sides by 2. That gives us 8x plus 6. 2 times 1/2 is 1, so we get 170 minus 5x plus 8. So we get 8x plus 6 equals negative 5x plus 178. Let's add that 5x over. We get 13x. Subtract that 6 over. We get 172. So x is going to be 172 divided by 13, which is that 8? I'm not sure. Let's check real quick. Okay. Let me see. 172 divided by 13. Ding, 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 ding. No. Did I make a mistake somewhere? NJ, 170 minus 5x plus 8. Oh, I did make a mistake. Oh, boy. I'm glad I saw that. Let's go back. This is very important. I'm glad I did it so I can show you guys. When we are subtracting a whole binomial like this, so we have to put the whole thing in parentheses. So we have 170. Let's get rid of this whole thing. Let's do the whole thing again. So we have the angle 4x plus 3 equals 1/2 of the difference between the big arc, which is 170, minus the little arc, which is 5. Ooh, and then we have to put it in 5x plus 8 because we're subtracting the whole thing. That is what I did, and that's very important to remember those parentheses. And you'll see why. So if I multiply both sides by 2, we get 8x plus 6 equals 170 minus 5x plus 8. Now I get 8x plus 6 equals 170. And you can look at this as plus negative 1 times 5x plus 8. It's the same thing. So when we distribute that, you'll see why that's important. So we get 8x plus 6 equals 170 plus negative 5x, because negative 1 times 5x is negative 5x, and negative 1 times 8 is negative 8. Ooh, that does very much matter. So I get 8x plus 6 equals 170 minus 8 is 162. And now we have minus 5x. That's important. So we get 13x plus 6 equals 162. 13x equals 156. And x equals, so 156 divided by 13. What is that? Can't do that in my head. Should be about 8. 12, I mean. 12. So we get 12. So x is 12. Oh, I meant to do number 12. Oh, great. So x is 12. So now we need to find the measure of MLK. So MLK. MLK we know is 4x plus 3. Let's change colors here after I erase this. MLK is 4x plus 3. So we get 4 times x, which is 12, plus 3, which is going to be 51 degrees. There we go. I was going to do, I'll just do number 12. That's the last one I'm going to do. Give you guys a little bit extra here. So we get dA, we are given. We are also given, kinda, dB. dB. And we are also given the angle. Call that 5x plus 11. So we can do the same thing. We have our intersecting lines outside the circle. So we know that 5x plus 11 is going to equal 1/2. The red. Do we know the red? We do. The red is going to be dA. That is 23x minus 14. So I'll put that in parentheses, minus. And then we have dB, which is going to be in orange, but is what it is going to be 9x minus 4. Ooh, this is some good math. So we get 5x plus 11 equals, I want to multiply both sides by 2 here actually. So no more 5x plus 11. Let's change colors to blue. I get 10x plus 22. The 1/2 and the 2 cancel. And I get 23x minus 14 minus 9x minus 4. So remember, you can write this as 23x minus 14 plus a negative 1 times 9x minus 4. So that's going to equal 23x minus 14. Negative 1 times 9x is going to be minus 9x. Negative 1 times negative 4 is going to be plus 4. So let's bring that up here. So we get 10x plus 22 equals 23x minus 9x. It's going to give us 14x. Negative 14 plus 4, negative 10. So I can add 10 to both sides. I get 10x plus 32 equals 14x. Subtract 10x from both sides. I get 32 equals 4x, which means x equals 8. Are we done though? No. We are looking for dA. So the measure of dA is going to equal 23 times 8 minus 14, which is going to be 170 degrees. And we are done. Okay, that should do it, guys.